What if I told you that 60 years ago engineers built bulldozers so insane, so brutally over-engineered that modern machines can't even touch them? We're talking walking dozers, nuclear-powered monsters, and machines that look like they crawled straight out of a sci-fi nightmare. These aren't CGI. These aren't concepts. These things actually moved dirt. Buckle up, because number 4 will break your brain completely. Number 1. Komatsu D475A A-3SD Superdozer. The Komatsu D475A-3SD Superdozer holds one of the most extreme records in construction history. It is widely recognized as the largest production bulldozer ever built. First introduced in the late 1980s and entering production in the early 1990s, the D475A was developed primarily for large-scale surface mining operations where sheer pushing capacity mattered more than mobility or transport convenience. The D475A-3SD variant is powered by a 12-cylinder turbocharged diesel engine, producing approximately 1,150 horsepower. Its operating weight exceeds 150 metric tons, which is over 330,000 pounds, depending on configuration. The Superdozer blade configuration can move roughly 69 cubic meters, around 90 cubic yards of material per pass, making it capable of shifting enormous volumes of overburden in open-pit mines. What makes the D475A truly unusual is not just its size, but the engineering compromises required to build something this massive. Transporting it requires disassembly into multiple components. It is not a machine you casually relocate between job sites. It was designed specifically for long-term deployment in massive mining environments such as coal and mineral extraction projects in North America and Australia. Despite its enormous footprint, the D475A maintains relatively precise control through advanced hydraulic systems. Visibility and operator ergonomics were also improved in later generations, showing that even the largest machines evolved towards safety and comfort. Unlike many oversized experimental machines of the 20th century, the D475A was not a one-off prototype. Multiple units were built and delivered commercially, confirming its place as a legitimate production machine rather than a concept experiment. Even today, it remains one of the most extreme examples of how far traditional crawler dozer engineering was pushed before practical limits, and transportation economics began to favor slightly smaller but more versatile machines. Number 2. Caterpillar D7E. The Caterpillar D7E represents one of the most unconventional drivetrain experiments ever successfully brought into mainstream bulldozer production. While most crawler tractors rely on mechanical transmissions or hydrostatic systems, the D7E uses a diesel-electric powertrain, a configuration more commonly associated with locomotives. Introduced in the late 2000s as part of Caterpillar's effort to improve fuel efficiency and reduce emissions, the D7E replaced the traditional transmission with a generator and electric drive motors. A diesel engine drives a generator, which then supplies electricity to electric motors that directly power the tracks. This design eliminates components such as torque converters and conventional gear systems. The concept of diesel-electric power was not entirely new in heavy industry, but applying it to a production crawler dozer was rare. The benefits included improved fuel efficiency compared to earlier D7 models, reduced maintenance due to fewer mechanical moving parts in the transmission system, and better torque delivery at low speeds, a key advantage for dozing operations. The D7E typically produces around 235 to 250 horsepower, placing it in the mid-size dozer category. While it does not rival the sheer size of mining giants, its engineering philosophy is what makes it strange in bulldozer history. Instead of increasing displacement or adding gears, Caterpillar fundamentally rethought how power reached the ground. Externally, the D7E looks fairly conventional. Internally, however, it represents a significant shift in design strategy, one that anticipated later hybrid developments in heavy machinery. For equipment historians, the D7E stands as proof that even in a mature industry like bulldozers, radical drivetrain innovation is still possible. Number 3. Caterpillar DD9G. Few machines look more outrageous than the Caterpillar DD9G, sometimes nicknamed the Quad 9. Built during the 1960s and 1970s, this machine essentially combined two Caterpillar D9G tractors into a single tandem unit operated by one person. Rather than designing an entirely new Superdozer chassis, engineers mounted two D9G power units together, linking controls so that a single operator could command both simultaneously. The result was a combined output of roughly 770 horsepower, two engines of approximately 385 horsepower each, delivering immense pushing power for large-scale earth-moving operations. The DD9G was primarily used in large civil engineering projects and mining environments where high-volume material movement was critical. The machine featured a massive blade spanning the front, capable of pushing more material than a single D9 could manage. From an engineering standpoint, the DD9G represents a brute force solution to a problem. When one dozer is not enough, use two. Instead of investing in completely new tooling and frame designs, Caterpillar effectively synchronized two proven platforms. This reduced development risk while dramatically increasing power. However, this configuration also came with challenges. Maintenance complexity doubled. Fuel consumption increased significantly. Transport and maneuverability became more complicated. These factors ultimately limited the widespread adoption of tandem configurations as single-chassis megadozers improved. Today, surviving DD9G machines are rare and highly prized among heavy equipment enthusiasts. It stands as one of the most visually dramatic examples of mid-century heavy machinery experimentation, a literal doubling down on power. Number 4. International Harvester TD9. The International Harvester TD9 is one of the foundational machines of early crawler dozer history. Produced beginning in the late 1930s by International Harvester, the TD9 was originally designed as a tracked agricultural tractor, but quickly became widely adapted for construction and industrial use. Unlike modern dozers built from the ground up as dedicated earth movers, early crawler tractors like the TD9 often began life as farm machines. Contractors and operators would attach aftermarket or factory blade kits, transforming them into bulldozers. This adaptability made the TD9 extremely versatile. Powered by a four-cylinder diesel engine with some early gasoline start configurations, the TD9 delivered reliable torque for its era. While modest by modern standards, its power was significant for pre-World War II construction sites. The tracked undercarriage allowed operation in muddy fields, logging sites, and road-building environments where wheeled tractors struggled. During World War II, TD series tractors were used in various military engineering roles, including airfield construction and logistical support. This wartime service further cemented the TD9's place in industrial history. What makes the TD9 strange today is how different early crawler engineering looks compared to modern equipment. Exposed linkages, minimal operator protection, mechanical blade controls, and relatively slow travel speeds highlight how far the industry has evolved. Many restored TD9 machines still operate in vintage tractor shows, demonstrating the durability of early crawler designs. For historians, it represents the transitional phase between agricultural tractor and purpose-built bulldozer, a critical evolutionary step in heavy machinery development. Number 5. Stalinets S65. The Stalinets S65 is one of the most visually distinctive crawler tractors ever built. Manufactured beginning in 1937 by the Chelyabinsk tractor plant in the Soviet Union, the S65 was developed as a heavy agricultural and industrial crawler tractor during a period of rapid Soviet industrialization. Unlike the refined, rounded designs of Western manufacturers at the time, the S65 featured a boxy, almost architectural appearance. Its large rectangular engine housing, tall vertical exhaust stack, and open operator station gave it a raw, utilitarian presence. It looked less like a farm tractor and more like a moving industrial block of steel. The S65 was powered by a diesel engine producing roughly 65 horsepower, modest by modern standards, but significant in the late 1930s. It was derived from earlier Stalinets models, which themselves were influenced by American tractor designs licensed during the early industrial collaboration period between the USSR and US. During World War II, production facilities in Chelyabinsk became heavily militarized, and the plant earned the nickname Tankograd, Tank City. While the S65 itself was primarily agricultural and industrial, Tractors of this class were used in engineering and logistical roles, including hauling artillery and assisting in military construction. What makes the S65 unusual in dozer history is its transitional identity. It was not originally a purpose-built bulldozer, but a crawler tractor that could be adapted with blade attachments. This modular philosophy was common in early crawler development worldwide. Today, restored S65 units are preserved in museums across Russia and Eastern Europe. They serve as reminders of early diesel crawler engineering and the massive push toward mechanization in pre-war Soviet industry. Its imposing, almost brutalist design makes it one of the strangest-looking vintage crawler machines ever put into mass production. Number 6. Allis-Chalmers HD6. The Allis-Chalmers HD6 represents a fascinating chapter in mid-20th century crawler development. Produced by Allis-Chalmers beginning in the 1940s, the HD6 was part of the company's HD heavy-duty series of crawler tractors designed for agriculture, logging, and construction. What makes early HD6 models especially interesting is their cable-operated blade systems. Before hydraulic cylinders became standard in bulldozer design, many machines relied on mechanical cable winches to raise and lower blades. These cables were wound around large drums mounted either at the front or rear of the tractor, powered by mechanical takeoffs from the engine. Operating a cable dozer required significant skill. Blade control was less precise than modern hydraulic systems, and the operator had to carefully manage tension and positioning to avoid slack or misalignment. Exposed cable lines and visible drum assemblies gave the HD6 a rugged mechanical look that feels almost nautical, more like maritime machinery than a modern construction vehicle. The HD6 was typically equipped with a diesel engine producing approximately 60 to 70 horsepower depending on configuration. Though relatively small compared to later giants, it was highly versatile. It was commonly used in logging operations, road construction, and farmland clearing. Another notable aspect of the HD6 was its durability. Many surviving units remain operational today, thanks to relatively simple mechanical systems that can be restored without complex electronics. Enthusiasts and collectors appreciate the HD6 because it represents the last era before hydraulics fully transformed dozer control. In historical terms, the HD6 marks the transition between purely mechanical crawler tractors and the more refined hydraulic machines that would dominate the second half of the 20th century. Its exposed winch systems and raw mechanical operation make it one of the most visually and mechanically distinctive vintage dozers ever built. Number 7. LeTourneau Tournatractor. Few names in heavy equipment history are as inventive as R.G. LeTourneau. Among his many unconventional designs was the LeTourneau Tournatractor, a machine that challenged the traditional idea that bulldozers must run on tracks. Unlike conventional crawler dozers, the Tournatractor was built on large rubber tires. The idea was to create an earth-moving machine that could travel faster between job sites without needing to be transported by trailer. This was particularly attractive during mid-century infrastructure expansion projects in the United States. LeTourneau machines were known for their electric wheel drive systems in some large scrapers and earth movers. And while not every Tournatractor used the same drivetrain concept, the company frequently experimented with electric power transmission in heavy equipment long before hybrid systems became common. The wheeled configuration offered advantages in mobility and speed, but sacrificed some traction compared to tracked dozers. Tracks distribute weight more evenly and provide better grip in soft soil. As a result, wheeled dozers never completely replaced crawler designs in heavy pushing applications. However, the Tournatractor remains historically significant because it reflects a period of intense innovation in earth-moving equipment. Designers were not locked into one solution. They experimented boldly with wheel arrangements, articulated frames, and alternative drive systems. Today, LeTourneau machines are highly collectible and displayed in museums, including large preserved examples in Texas. The Tournatractor stands as proof that even something as seemingly fixed as a bulldozer must have tracks was once challenged by visionary engineers. Number 8. Caterpillar D8H. Cable Blade Era. The Caterpillar D8H is one of the most iconic crawler tractors ever produced by Caterpillar Inc. Introduced in the late 1950s, the D8H became widely used in construction, mining, and land clearing operations worldwide. While later D8 models were fully hydraulic, early D8H configurations were available with cable-operated blade systems. These versions featured large rear-mounted winches and visible cable routing to control blade lift. Just like the Allis-Chalmers HD6, this mechanical system required operator precision and experience. The D8H typically produced around 270 horsepower, depending on configuration, making it significantly more powerful than earlier mid-century crawlers. It represented a step forward in both engine design and structural durability. What makes the cable-equipped D8H particularly fascinating is that it bridges two eras. It had the size and strength approaching modern Dozers, yet retained the mechanical blade control systems of earlier decades. It looked powerful and modern for its time, but still operated using steel cables rather than hydraulic cylinders. Thousands of D8H units were produced, and many remained in service for decades due to their robust build quality. Even today, restored D8H machines appear in working demonstrations at equipment shows. The D8H helped cement Caterpillar's dominance in heavy crawler manufacturing, and the cable blade versions represent one of the final chapters of purely mechanical blade control before hydraulics became universal. Number 9. Caterpillar D9R, D9T. The Caterpillar D9 has been in production in various forms since the 1950s, but the D9R and later D9T variants became especially unusual when adapted into armored engineering vehicles. Originally designed as civilian heavy construction and mining machines, certain D9 models were modified with protective armor kits for military use, most notably by the Israel Defense Forces (IDF). The D9R, introduced in the 1990s, typically produces around 410 horsepower, while later D9T variants increased power output to approximately 436 horsepower depending on configuration. In civilian form, these machines are used in mining, quarrying, and large-scale construction projects. However, once armored, they transform into something far outside the normal identity of a bulldozer. The armored versions are fitted with reinforced plating around the cab, engine compartment, and hydraulic systems. Bullet-resistant glass protects the operator, and additional shielding is added to critical components. These modifications allow the machine to operate in hostile environments where standard construction equipment would be too vulnerable. The D9's heavy weight, often exceeding 50 tons in standard configuration, makes it inherently durable. Combined with armor upgrades, it becomes capable of clearing debris, pushing barricades, removing obstacles, and even detonating explosive devices from a protected position. What makes the D9R and D9T especially strange in bulldozer history is their dual identity. Mechanically, they remain conventional heavy crawler tractors with large blades and optional rear rippers, yet visually and operationally, armored versions resemble combat engineering vehicles more than construction equipment. Unlike experimental military prototypes, these armored D9 units have seen documented operational use. Their existence demonstrates how adaptable industrial machines can become when modified for extreme environments. In the long timeline of crawler tractors, few examples blur the line between civilian machinery and battlefield engineering as dramatically as the armored D9 family. Number 10. Komatsu D475A. The Komatsu V475A stands just below the D575A in Komatsu's lineup of ultra-large dozers, but it remains one of the largest production crawler tractors ever manufactured. Built by Komatsu, the D475A was introduced in the 1980s and has gone through several updated generations. Depending on the specific version, such as the D475A5 or later Ration 8 variants, the machine produces roughly 890 horsepower. Operating weight typically exceeds 100 metric tons. It is designed primarily for mining applications, including overburden removal and large-scale material pushing in open-pit operations. While not quite as enormous as the D575A, the D475A is still significantly larger than most conventional construction dozers. Its blade capacity and pushing force make it suitable for projects that require sustained high-volume earth-moving over extended periods. What makes the D475A historically interesting is its role in the steady escalation of dozer size during the late 20th century. As mining operations expanded and equipment became more specialized, manufacturers competed to build larger and more efficient machines. The D475A represents a mature stage of that evolution, large enough to dominate mining sites but still practical enough to be transported in modular components. The machine incorporates advanced hydraulic systems, improved operator visibility compared to earlier decades, and reinforced undercarriage components to handle extreme stress. Later versions also included improvements aimed at fuel efficiency and emissions compliance. Unlike experimental machines or limited prototypes, the D475A has been commercially successful and widely deployed across global mining operations. Its size, power, and engineering refinement make it one of the most formidable crawler tractors ever produced, and a fitting conclusion to a list of strange, extreme, and historically significant vintage dozers. So that's it for today. If you like this video, then please hit the like and subscribe button for more videos. Thanks for watching.